It's a cold January night in 1929, high in the San Gabriel Mountains above Los Angeles. Inside the dome of the Mount Wilson Observatory, Edwin Hubble positions himself at the eyepiece of the 100-inch Hooker telescope. At the time, the largest telescope on Earth, he's been measuring light. Not just any light, but light that left distant galaxies millions of years ago, light that has travelled unimaginable distances to reach this mountain, this telescope, this moment. And as he plots his measurements on paper, galaxy after galaxy, something impossible begins to emerge. A pattern, a rhythm, something that shouldn't be there if the universe is what everyone believes it to be. The numbers are telling him that the universe is not standing still. They're telling him it's running away. For all of human history, we had asked the same fundamental question. What is the universe? Is it eternal? Has it always existed, unchanging and infinite, like a cosmic stage on which stars and planets perform their dance? Or does it have a story, a beginning, an end? By the early 20th century, we had the tools to finally answer this question. We had Einstein's equations describing how space and time bend and flex. We had powerful telescopes that could peer deeper into the cosmos than ever before. We had photography that could capture light too faint for the human eye. But we didn't have the answer because the universe we believed was static, permanent, eternal. To suggest otherwise, to claim the universe had a beginning, seemed less like science and more like philosophy or religion. The mystery wasn't just what the universe was, it was whether we were brave enough to follow the evidence, even if it led somewhere uncomfortable. In the 1920s, the prevailing view of the cosmos was simple and comforting. The universe was a vast, unchanging collection of stars. It had no beginning. It would have no end. It simply was. Even Albert Einstein, whose theory of general relativity had revolutionized physics, believed this. When his own equations suggested the universe might be expanding or contracting, he rejected the notion. He actually added a mathematical term, the cosmological constant, to force his equations to describe a static universe. It wasn't stubbornness. It was common sense. Everything we could see suggested permanence. The stars were fixed in their positions. The galaxies, though we had only recently discovered they existed beyond our own Milky Way, seemed frozen in place. But there were cracks forming in this comfortable worldview. Astronomers like Vesto Slipher had noticed something strange. When they analysed the light from the distant galaxies, it was shifted toward the red end of the spectrum. Redshift. It was the same effect you hear when a police siren passes you on the street. The sound waves stretch as it moves away. If galaxies were redshifted, they were moving away from us. But how many? And how fast? And what did it mean? That's where Edwin Hubble came in. Hubble was not a man who rushed to conclusions. Trained as a lawyer before turning to astronomy, he approached the cosmos with methodical precision. Night after night, he used the Hooker telescope to photograph distant galaxies, measuring their light with painstaking care. He was building on earlier work, the discovery that certain stars called Cepheid variables pulse with a rhythm directly related to their brightness. By measuring how bright they appeared from Earth, you could calculate how far away they were. It was like having a cosmic measuring tape. Galaxy by galaxy, Hubble measured distances, and galaxy by galaxy, he measured redshift. Then he plotted them on a graph. What emerged was stunning in its simplicity. The farther away a galaxy was, the faster it was receding. Not randomly, proportionally, mathematically. It was a law, a fundamental property of the universe. The universe was expanding. But Hubble wasn't the only one to reach this conclusion. 3 years earlier, in 1927, a Belgian physicist and Catholic priest named Georges Lemaître had published a paper, largely ignored, proposing the exact same thing. Using Einstein's equations, Lemaître had reasoned that if the universe was expanding now, then it must have been smaller in the past, much smaller. In 1931, Lemaître took the idea to its logical conclusion. If you ran the clock backward far enough, you'd arrive at a moment when all the matter and energy in the universe was compressed into a single point. He called it the primeval atom, a cosmic egg from which everything hatched. It was the idea that would eventually be called the Big Bang. When Lemaître presented his theory to Einstein in 1933, the great physicist stood and applauded. He called it the most beautiful explanation of creation he had ever heard. Einstein later admitted that adding the cosmological constant to keep the universe static had been his greatest blunder. The discovery of an expanding universe didn't just change cosmology, it changed philosophy. It changed how we understood time itself. For the first time in history, science could say with confidence the universe had a beginning. Approximately 13.8 billion years ago, everything, all matter, all energy, all space, all time, emerged from a singular, impossibly dense point. The universe wasn't eternal. It was born. Naturally, not everyone was thrilled. Many scientists resisted. The idea of a cosmic beginning sounded too much like the Genesis story. It seemed unscientific, even mystical. British astronomer Fred Hoyle famously mocked it, coining the term Big Bang as an insult. He championed an alternative called the steady state theory, where the universe had no beginning and continuously created new matter to maintain its density as it expanded. The debate raged for decades. Ironically, Georges Lemaître, the Catholic priest who conceived the theory, was uncomfortable with religious interpretations. When Pope Pius XII enthusiastically embraced the Big Bang as proof of divine creation, Lemaître quietly pushed back. For him, science and faith occupied separate realms. His primeval atom was physics, not theology. The turning point came in 1964. Two scientists at Bell Labs, Arno Penzias and Robert Wilson, were trying to eliminate mysterious static from a radio antenna. No matter what they did, a faint hum persisted. It came from every direction in the sky, constant and unchanging. They had discovered the cosmic microwave background, the afterglow of the Big Bang itself, the faint heat signature left over from the universe's fiery birth, cooled over billions of years, but still detectable. Georges Lemaître learned of the discovery just days before his death in 1966. The primeval atom was real. Today, the Big Bang's not a theory in doubt. It's the foundation of modern cosmology. We now know the universe is not only expanding, it's accelerating. Driven by something we call dark energy, galaxies are racing apart faster and faster. We've mapped the cosmic microwave background in exquisite detail, seeing the tiny temperature fluctuations that would eventually grow into galaxies. And we've looked back in time. When the James Webb Space Telescope captured its first images in 2022, it wasn't just looking into space, it was looking into history. Because light takes time to travel, every distant galaxy we observe is a fossil. A glimpse of the universe as it was billions of years ago, Webb has seen galaxies forming just a few 100 million years after the Big Bang. It's observed stars like Earendel, whose light is nearly 13 billion years old, born when the universe was still in its infancy. We are watching the beginning of time unfold. But the legacy of Hubble and Lemaître goes beyond telescopes and equations. They gave us a new story about ourselves. A story where the universe is not a backdrop, but a narrative. Where time has a direction. Where everything that exists, every atom in your body, every star in the sky shares a common origin. In 2018, the International Astronomical Union officially recognized Lemaître's contribution. Hubble's law was renamed the Hubble-Lemaître law. It was a small gesture, but it mattered. Because science is not just about discovery, it's about remembering who made the discoveries, and why they had the courage to question what everyone else believed.